Hi class, today we're going over lesson 7.7, simulating compound events. So, a simulation is a model of a real-world situation that can be used to find probabilities. So what we're going to do is we're going to take a real-life example and we're going to find certain tools that we have to model that probability. And finally, a compound event is an event that consists of two or more events. It's a definition we had from 2 chapters ago, but we're going to keep using it today. So our key concept, a simulation uses a tool like a spinner, a dice, or a coin for which outcomes have the same probability as the actual event. A greater number of trials will usually give results that are closer to the theoretical probability of each of the actual event. So let's start with our first example here. So Margot scores a goal for her team every 2 out of 3 shots. She assigns the values 1, 2, 3, and 4 on her dice to be goals and 5 and 6 to be misses. So does this make sense? Well, if she's scoring every 2 out of 3 shots, we want to use something to model that also scores every 2 out of 3 shots, right? So we want to find something that has a probability of 2 out of 3. So let's look at our dice. We have 1, 2, 3, and 4. These are going to be goals. I'll highlight them yellow. These are our goals. And 5 and 6 are going to be our misses. I'll highlight them pink here. So let's think. When we're rolling a dice, what's the probability that we are going to land on either a 1, a 2, or a 3 out of 4, or a 4? It'd be 4 out of 6, right? 4 out of 6, and we're going to simplify that down to 2/3. And then landing a 5 or a 6 would be 2 out of 6, which is equal to 1/3. So would this make sense that she is using this, her 1, 2, 3, and 4 to show goals and 5 and 6 to show misses? Well, yes, right? And the reason is because this 2/3 right here is equal to this 2/3. They're the same number. So we know that she is using a good tool to model it there because we're getting the same probability. All right, so now we want to choose the best tool to carry out the simulation. So for starters, we have Jeremy makes half of his free throws. Well, what's something that you guys know that we've used a lot that would have a 50% probability? Flipping a coin, right? Because flipping a coin, you have a 50% chance to get heads and a 50% chance to get tails. All right, let's go to the next one here. Alma guesses correctly on her test 2 out of 3 times. Well, this is pretty similar to the next example. We could use a number cube or a dice. So 1 through 4 is correct. And a 5 through 6 is incorrect. And so that would model our Alma's guessing correctly. And then finally, Jeremy catches the imposter 7 out of 9 times. Well, we could use a spinner with 7 green and 2 blue. So green could be catching and blue would be not catching. All right, so there are 3 different options, all tools we can use to carry out a simulation. All right, so Julie uses a number cube to simulate a flower seed sprouting, for which the success rate is 50%. She used even numbers to represent success and odd numbers to represent failure. So the result of 8 trials that simulate the sprouting of 5 seeds are shown below. And based on the simulated results, what is the probability that none of the next 5 flower seeds will spot successfully? All right, this one looks very challenging, but it's a bit simpler than we are originally thinking. So she said that all the even numbers show that something sprouted successfully, right? So what we want to do is we want to find out which of these numbers have even numbers in them here. So 3, 1, 5, 3, 4. Well, 4 is an even number, so this one would have sprouted correctly. 3, 5, 6, 3, 5. 6 is an even number, so this one sprouted correctly. 4, 3, 6, 3, 1. There's 2 even numbers in there. 3, 5, 6, 3, 3. 1 even number in there. 2, 5, 1, 4, 3. Again, 1 even number. 2, 5, 6, 4, 3. We got 2 even numbers. 6, 4, 1, 3, 3. 1 even number. And then 5, 3, 1, 1, 3. Well, there's no even numbers in there. All right, so out of our results here, we have 1, 2, 3, 4, 5, 6, 7. 7 that sprouted correctly, 7 out of 8. So, based on the simulated results, what is the probability that none of the next 5 flower seeds will sprout successfully? It would be a 1 out of 8 chance, right? Because 1 of the 8 total outcomes did not sprout successfully. All right, so today we talked about simulation and we used that to predict an event, and we also talked about different tools that could be used in different events to model probability. So that's the end of our lesson here for today and the end of chapter 7. I will see everyone